Hey, we are ready for section 9B about solution concentration. You see there aren't many slides, but these slides do have some writing, and in just a little bit we'll get a little bit mathematical as well. One thing that I know you'll like to hear, this is our final set of notes of the first semester. That sounds great, but that means after we take this chapter test, we start getting ready for the semester exam, which covers everything we have done so far. More about that coming a little bit later. Right now, let's talk about 9B, solution concentration. Ready to begin? Saturation. On this page, you're going to see 4 definitions that are very related to each other. Concentration is actually the amount of solute that really does dissolve in the solution. Now, sometimes if we put too much solute in, for example, too much sugar in the iced tea, not all that we put in will end up dissolving. So concentration is how much actually dissolves in the solution. Now, obviously, the more that dissolves, the higher the concentration. The less that dissolves, the lower the concentration. Now, all solutions have a point in which we cannot get any more of the solute to dissolve. Remember, we talked about solutes and solvents last time. We call that saturated. At the same temperature, we have reached the maximum. There will be no more dissolving even if we put more solute in. That is called saturation. In order to get more solute to dissolve, we will have to raise the temperature, maybe put the liquid in the microwave if it's microwave safe, and warm up or heat up on the stove. Unsaturated, well, obviously the opposite. If saturated means the maximum can't dissolve anymore, well then unsaturated means there's still some solute that we can add and get to dissolve at the same temperature. So saturated means we have hit the maximum. Unsaturated means we have not yet hit the maximum. We still may be able to dissolve more without warming up the solution. And then there is supersaturated. Now in this case, here's a definition. Heated saturated solution slowly cools down and maintains dissolved solute. So when we reach this maximum, if we want more solute to dissolve, heat up the solution. Then we can put in more solute and then let that solute cool down gradually on its own. And if the change in temperature decreases gradually enough, then the solute will stay dissolved a lot more. Okay, and in a few minutes we're going to talk about a little bit about making fudge, and you'll see on page 217 a little bit what I'm talking about and how that we can get thicker and stiffer fudge. Concentration, how much dissolves. Saturated, maximum, no more will dissolve. Unsaturated, not yet at the max, so we can dissolve more. Supersaturated, heat it up, dissolve some more, slow down or cool down very slowly, and everything stays dissolved. Ready? All right, calculating the concentration. You see the word calculating. That means some math is coming up. Percent is the mass of the solute over the mass of the solution. I'm going to put that more in vertical up and down form. Percent is the mass of solute over the mass of the entire solution. Spell that right. Now it looks a little more like you're used to. For example, your test score. Let's assume you take 50 questions and every question is 2 points. Now assuming that all the answers are worth the same number of points, then you have a percent, which is the total you got correct over the total number of questions. So you may have 36 correct answers out of 50 questions. That's going to be 0.72. And remember to change that to a percent by simply moving that decimal over and adding the percent sign. Hopefully you'll get better than that, and I wasn't in the way too much as I wrote that. Okay, but that's how we calculate a percent. It's what we're talking about divided by the total. Okay, in this case, 100 grams of bleach has 5 grams of sodium chlorate. What's the percent of the solution is actually sodium chlorate? All right, let's put this back on. And let's see, the percent is what we're talking about. So in this case, we're talking about the 5 grams of the sodium chlorate divided by 100 grams of the entire solution. Now I know that this can get in the way and this can get in the way. The grams are going to cancel. As far as the calculation goes, we don't really have to worry about that. So let's just do the division and you'll get 0.05. And simply remember to change that to a percent. 1, 2, and now you have 5%. But in your answer, make sure you go back and put what we're talking about here. Now my writing, you know, is not the best. So we have 5% is sodium chlorate. And it'll be neater now. 5 grams of that sodium chlorate divided by 100 grams of the entire bleach solution, that means 5% of that solution is sodium chlorate. Now it works out to 5 only because we're dividing 5 by 100 to get 5%. You know, if this was 25 divided by 50, we'd get 50% here. So don't let the fact that that was 5 make you automatically think the answer is going to be 5. It's 5 only because of the 100. Of course, you know how the numbers work. But that's how we calculate the concentration. What we're talking about in this case is the sodium chlorate divided by the entire solution. Ready? Now, calculating concentration, what if we already know the percent and we want to know the mass of the solute? So the percent, remember, is the mass of solute divided by the mass of the solution. What we're talking about divided by the whole thing. Okay. So in this example, how many grams of salt are needed to make 175 grams of 13.1% salt solution? Okay, remember, percent equals what we're talking about, the solute, over the whole solution. So in this case, our percent is 13.1%. We're trying to figure out how many grams of salt we need. The entire solution is 175 grams. Okay, now all I have to do is a simple multiplication here. So the grams of sodium in this will be, now 13.1% is 0.131 times the 175, and we'll get the answer. It's approximately 22 grams. So I'm going to do approximately here. You're going to see the exact number as we put the typed words on the screen. The percent is the mass of the solute divided by the mass of the solution. 13.1% is equal to the grams of sodium that we're trying to figure out divided by the entire solution of 175 grams of that solution. We're going to multiply. Move that denominator over here and multiply to isolate the grams of sodium. So 175 grams, remember this is 13.1% changed into a decimal, and we get 22.925 grams. So I had 22, I estimated, it's closer to 23, but estimation is a great way to know that we did the question correctly. So we have approximately 22.925 grams of sodium in this particular solution. We'll do some practice problems throughout the rest of the chapter. Ready? All right, boiling point elevation. Okay, what does that mean? That means that the boiling point of a solution could actually go up from normal based on how much solute we put in. As we put in more solute, the solute increases, the solution's boiling point will also increase because there's more vapor pressure. There's more stuff in there forcing molecules to move around. That's going to make the vapor inside put a little bit more pressure in and raise what normally would be the boiling point of that particular fluid that's acting as a solvent. Yeah, I mentioned a few minutes ago about a little story of candy being made on 217, a little more specifically kinds of fudge. If you were to look at that picture and read the paragraphs, you'll see the description of the boiling point of the temperatures of the different kinds of fudge changing because of how much solute got dissolved. The higher temperatures are needed because more solute gives various types of candy and texture. So more solute becomes more concentrated. That's where you're going to get the stiffer, thicker fudge, and less of the solute, the flavoring and the cocoa and all the other ingredients. That's going to give you less texture, so you're going to have softer fudge. And maybe if there's way too much, it'd be hard to solidify. But if you want good, thicker fudge, put in more solute. And that seems like common sense, but the math shows that that's correct also. Ready? And we're very close to the end here. The freezing point depression, well, depression means going down. Okay. As more solute decreases, the freezing point because of the lower vapor pressure. So if we add more solute, the boiling point goes up a little bit, but the freezing point will actually go down. And that's because of the lower vapor pressure when we condense and then start to freeze. For example, salt lowers the freezing point of water to below 0 degrees. Normally, water freezes at 0 degrees Celsius. But you may notice in some northern cities that get very icy roads, city officials will come by and put salt on the roads to help melt the ice. That salt lowers the freezing point of water, so that water does not freeze into ice and will run off the road and make the roads safer to drive on. The salt melts the ice on the roads, and that's because the freezing point is lower, so the water hasn't reached that correct freezing point now with the salt added on. All right, homemade ice cream, think of that. Uses lower freezing points so the ice cream may remain soft. Many people like the soft ice cream better than the harder ice cream that you might buy in cartons. Well, if you like the softer ice cream, you want the lower freezing point. So salts are put into ice creams as well to help lower that freezing point and get a soft serve ice cream. So freezing point depression, the solute decreases the freezing point because there's lower pressure. Ready? Larger liquid temperature range. What is this all about? Well, this means that the boiling point will go up and the freezing point will go down. The larger range temperatures becomes very useful. Think of the engines. We need to use antifreeze. What is antifreeze? It's a thick fluid that helps regulate the temperatures of the radiators so the car doesn't break down. In a car radiator, the same fluid, antifreeze, which scientifically is called propylene glycerol, can be both a coolant and an antifreeze. The coolant to help keep the engine cool if the engine starts to get too hot, and to keep the engine from freezing in the wintertime if the engine starts to get too cold. Well, by raising the boiling point and at the same time lowering the freezing point, that gives a larger temperature range to keep that radiator in good working condition. And that's a good thing, and that's why engines need to have antifreeze. Now, some people use water in emergencies, but you want to get that water out of there and use antifreeze to help give a bigger temperature range to keep that radiator in good working condition. Ready? All right. We have just finished the first semester of notes. We do have some assignments and a chapter test coming, and then we will start getting ready for the semester exam. But as always, concentration is the solution to success. See you later.